Good evening, everyone. I'm Shava Desire, and I'm going to present my CV analysis AI project. I'm going to first talk about the problem. The problem I'm trying to solve here is reducing the hectic work of for the employers or recruiters, the work that they pass through, trying to pass through the resume or CV documents for the different candidates that tend to be maybe so many, being that they're from different applicants. So this one is to help in easing the process. In this project, I'll be using a dataset called resume dataset. This contains text from various resume types and can be used to understand what people mainly use, what is commonly used in the CV documents, and just to help also to understand the profile of the applicants, the skills they possess, and all the qualifications to compare them with the employer's need or want. Under this dataset, there are some terms that I would like to share, like tokenization. This is a process of breaking raw text into small units and ease to process units. That they're easy, let's say breaking down the information and categorizing it into small units for easy processing. Then lemmatization. This involves the process to group together the different forms of a word. There are some words that can be used in the CV but all mean the same. So this one helps, if a word has a same meaning with some several words, it's categorized in one group so that the AI is makes it easy for it to just identify its meaning or not its meaning. Then frequency distribution. This one is a feature to show that how many times the word has appeared in several documents or CV samples. And for the word cloud, this is where after of course getting the reference distribution, you make a word cloud you give the AI that a set of words, common words that are highly used, especially categorized according to maybe careers. Let's say someone who's coming for an IT technician, they can get some words maybe an IT technician, those are the words, and some common terms that the other one will use, maybe for skills or something of a sort. So it may depend on the career. Then here, I'd like to briefly talk about the Bayesian theorem. Bayesian theorem is a method to determine conditional probabilities, that is to say the probability of one event occurring given that another event has already occurred. The way it works, it allows updating the probability prediction of an event by observing new information of the real world. Following are some applications of the Bayesian theorem. It is used to calculate the next step of the robot when the already executed step is given. The Bayesian theory is helpful in rather forecasting. It can also solve the multi-hole problem. Now, in this slide, I would like to show In this slide, I'm going to kind of show how we can express the Bayesian theorem in the mathematical way. Now, since the Bayesian theory deals with the probabilities and all that, we are giving two events, one event which is X and another one is Y, and follows. So we try to make two equations but when we get these equations, like to combine them, we come down with the formula below, as you can see it there. The next page. This is a machine learning algorithm we use to solve classification problems. It is based on the Bayes theorem. It is one of the simplest yet powerful machine learning algorithms, the ML, in use and finds applications in many industries. The naive Bayes uses the Bayes theorem and assumes that all predictors are independent. In other words, this classifier assumes that presence of one particular feature in a class doesn't affect the presence of another one. Merits. It has, like for anything else, it always has merits and demerits. So some of the merits of the naive Bayes: these algorithms works quickly and can save a lot of time. It is also suitable for solving mode-class prediction problems. It just assumes like independence of features and holds them true. It can perform better than other models and requires much less training compared to the rest. Everything is also better suited for categorical input variables than numerical variables. For the demerits, it assumes that all predictors are independent, rarely happening in real life, and yet this AI will be like the main goal for it is to work like in the real life. This algorithm also faces like zero frequency problem, where it assigns zero probability to a categorical variable whose category in the test data set wasn't available in the training dataset. It would be best if you use the smoothing technique to overcome this issue. Another term I'm going to talk about is the Bayesian leaf network. This is a key computer technology for dealing with probabilistic events and to solve a problem which is uncertainty. We can define the Bayesian network as a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed cyclic graph. It is also called a Bayes network, a decision network, or Bayesian model. Here we can also talk that because these networks are built from a probability distribution and also use probability theory for the prediction and anomaly detection. Anomaly, I can say it's like selective. So Bayesian network can be used for building models from data and expert opinions, and it consists of two parts: directed cyclic graph, table of conditional probabilities. The generalized form of a Bayesian network that represents and solves decision problems under uncertain knowledge is known as an influence diagram. The difference, the difference here, it may sound a little bit tricky, but what we should know that a naive Bayes, first of all, is just a classifier, and for the Bayes theorem, it's a theorem. But here, that one, of course, it's not that strong. It's a weak difference, but the naive Bayes or assumes conditional independence, where the Bayes theorem does not. This means the relationship between all input features are independent. May be not a great assumption, but this is why the algorithm is called naive. This is also one reason the algorithm is very fast. The difference between the naive Bayes and the Bayesian networks. Our Bayesian network models relationships between features in a very general way. For it, it models relationships between features in a very general way, while for the naive Bayes classifier is a simple model that describes particular class of a Bayesian network where all the features are class conditionally independent. Here are some of the links, like in case you would like to get maybe proof to some of the information I've tried to talk about that is in my research or in my slide, my presentation. I refer you to these links and you'll get more detailed information than what you have seen here in my slides. Thank you.